So today we got a little bit of bonus material on the Ruby language. So we kind of avoided some concepts. I have been avoiding some concepts, specifically object-oriented programming. Today we sort of covered that a little bit deeper. This is still very introductory. I remember in university, my first time around, object-orientedness. Well, I mean, it's not entire courses devoted to it, but we're talking weeks even. Object orientedness is a very deep concept, so we can really only brush the surface. So, toward that end, we're going to be looking at active records, so some of these methods that we use to perform these CRUD operations. And this is where that object orientedness comes in classes and objects. Figure out what the distinction between these two things are. They're very closely related. And we'll talk about instance methods. So this is something we will define on our active record objects, and hopefully having some a broader sense of what object-orientedness is. This will be a little bit easier to adopt or to internalize, I suppose. So I will probably be dipping in and out of these slides here and there. This, I think, is pretty much review. You should have done some of this as part of your coursework last day, I think. Does this look familiar at all? The find method specifically? I know some of you I had to help because some of your data got mangled going into the database. So maybe not all of you have seen this. But what we see here, here's our post model. This is that thing that sits in the apps/models directory, and it says post less than active record base. This is an active record object that provides another layer of abstraction over top of our database. When you create a database record, without fail, you're always going to have a unique identifier. Now, a very simple database management system like SQLite just starts counting at 1. You start using database systems like Postgres or MySQL or anything like that, you get not strictly randomized, but you get a very long string of characters that is very likely to be unique. It's kind of a strange thing to say, right? So it is kind of random, but there's a remote chance, from the beginning, the creation of the universe to its eventual demise, that this algorithm will produce the same number, right? It's infinitesimally small, but it's there. And given a long enough timeline, anything can happen. So not something super important, it's just a point of interest. But we can use these identifiers, and we can use this very basic method defined on the active record object to find a specific record by that identifier. So here we've assigned a value to the ID variable, which is 1. And you guys created 3 users. So this is kind of analogous. You created like Kirk Whalum and Sharky J, and what was the other one? Can't remember. Marlin Peppa, right. So each of these guys has a unique ID. So if you went to your Tux and you said, find me post with the ID 1, you're probably going to get, I think it was Sharky J is the first one. So yeah, you can find it based on that ID. We can also, and this should be familiar to those of you who've had some exposure to SQL, we can match on specific criteria. So we don't always have to know the ID. And in fact, we seldom do. It's not something we ever monkey with. We never change it. We just don't touch it. We know it's there and we know it's unique. Much more often, we will say, call a method like this. We just want to find one user, or maybe there's 2 users. There could be multiple users. It depends on how you set up your system. But we want to find out which users have this email address, and it's going to. Is this one good? I can't remember. I can never remember. I think find by will return all the matches, or maybe just the first one. Something to ask Google anyway. Just another method, another way to query our databases. So this would be the R in CRUD, reading. So again, some very helpful methods, and you've already seen this one, the all method. This is kind of a weird one to use if you got like a million posts on your Instagram application. It's going to take forever to load all those things up and then send them back to the client. So this is kind of a shortcut, hacky type of thing. But what it does is exactly that. It will retrieve every single one of those records and store it in an object over which you can iterate, and you can post or create content using your ERB files. Any guesses as to what this one does? Just by looking at it. Yeah, exactly. I think maybe that was too obvious. So this is that relation, right? So we know we're going to have Sharky J in there somewhere, and he's going to be posting all sorts of stuff. Chances are, he's going to have more than one. So all the records where these criteria match are going to be returned. So we could also say add another key value pair in there and say, well, we only want posts from this specific date. So we would query that created at field and say, okay, well, I want every post from September 27th, 2016 or something like that. So we can stack these things up and refine our search to any degree until the point, of course, where we don't get any results back. So, okay, so this is your, well, you know what, let's pause here. So this is kind of the break here. This is the active record stuff. Is any of this difficult? No, I think this is sometimes classes are very verbose, and sometimes you guys just sit here quietly. And I always see you shaking your head like this or going like this. So you are from now on my favorite student. I like that feedback. Yeah, a lot of this stuff will come out in demo as well, or through the course materials. So, but these are just, there's lots of different methods, lots of different ways that we can perform these various CRUD operations. And the ones we focused on here have been retrieving data from the database or reading data from the database. So, object-orientedness. I think at its core, it's fair to say that we organize an object-oriented program by class first. Now, that's kind of a difficult thing because there's also this a notion of modules, which further contain code. But a class, is similar, I guess, in the biological sense of a taxonomy. And I think I'll incorporate this into the demo. You have certain categories, and certain categories fit under certain classes. And you can have a top parent class, which we do, and then subclasses on that. And you can go down, 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 deeper and deeper. The class is very much like the blueprint. So, on my street, my neighborhood was built early 2000, 2001, 2002. You can go up my street and you can see identical models of houses. The blueprint for these houses would be directly analogous to a class. Those individual houses, on the other hand, are objects or instances of a class. So we can use this blueprint and create as many houses as we want, which was exactly what was done. So it's the difference between something concrete and something non-concrete. So the abstract class is non-concrete. You create a new instance of this class, you have a tangible object. You have that physical house on the street. That's the difference. And you see a couple of new methods here. The new method, just like when you're creating your active record objects, it has a new method, which creates a brand new instance of this class, a brand new house on the street, so to speak. Defining the class is very simple. You simply pass it this class keyword and the name of the class, and cap it all off with an end. So remember, whenever you're opening up a block of code like this, it's a good idea to write that end in there right away so you don't get some weird indentation or syntax errors. Inside this class, you define the methods, and this is what we'll show you. Okay, so let's pause there. Let's do some demo stuff. We're going to stay on this slide. There's my lovely wife selling stuff on our community auction site. Okay. Week 4. Let's see, what is this? September. Week 4, day 1 demo. See, this is why I should have sat down. It's hard to type. Let's say class demo. Let's just say class demo. If we need anything else, or let's say object-oriented demo. Object-oriented programming, demo. All right, so we're going to make this a blank one. We don't need anything. We'll just, where's my blank tutorial? There we go. Here we go. Normally I'd have all this set up, but now I got to man the front door, which is okay too. Okay, so, excuse me. So I'm going to adopt a very familiar concept. So I've sort of used that concept in biology. We call it taxonomy. So you have certain, I guess, what are the terms here? Genuses and species. And I was never into biology, so I don't really know. But this is kind of how our classes are organized. And when we're talking about classes, we're almost always talking about nouns, always people, places, and things. Then we have inside of these things called methods inside these classes, which are the verbs, the actions that we can perform on any instance, or in some cases, on the entire class itself. So what I'm going to do is create an animal class in a new file, and I'm just going to call it animals.rb, just an ordinary Ruby program. Currently, there's nothing in it, but I'm going to define a class called animal, just like, hilarious, class animal, just like that. And, just to show that this is actually working, let's say puts animal.new. So whatever's going to happen here, I've defined a class. It doesn't do anything. It's just empty. It's got some stuff it's inheriting from the base class in Ruby, but really it's not especially useful. What's going to happen when I execute this program, though, it's going to allot a space in memory, and it's just going to say, okay, hold this thing for this code construct there, and then print out the stringified version. That's that put s. To make that clear, let's do this. We'll say animal equals. So I'm going to assign it to a variable, and I just want to see whatever's inside that, whatever Ruby will show to me. So run my new program, animals.rb, and there you go. And you even get this benefit of this hexadecimal address. So if you think of your memory, this is the RAM inside of your computer. Probably a good amount of RAM is to have 8 gigabytes. Inside that, there's strings of bits and bytes, usually about 64 bits long, depending on how big your processor is, 64 bits versus 32. This is a 32-bit processor. You guys probably all have 64. It finds that place. It allots it, and that's the actual physical memory address. It's sitting there, and all the ones and zeros are all lit up. So nothing much there. So, but now here, well, you know what? Let's do this. Let's add an initializer. We want to add some value to this class. We want it to actually do something. Now, every class has what's called the initialize method. And what I want to do is I want to initialize it with this value weight. So every, unless it's like some creature made out of electrons, it's going to have, some substance to it. I guess even electrons would as well. neither a biologist nor a physicist, so I'm not really sure. But it's going to weigh something. And I'm going to assign this value to an instance variable called weight. So you've already seen instance variables, and you know that they're special because in your actions file, you can put values into these variables and then retrieve them from your ERB files. Same kind of thing holds true here, and I'll show you in just a second. So yeah, I want to go real slow here. If I run it now, it's going to say I'm expecting one parameter and 0 were provided. Watch what happens. So there's going to be an error. Wrong number of arguments. I was given 0, I expected 1, so I was pretty close. Sentiment, at least identical sentiment, maybe different words. The reason for that is because every time you call this new method, one of the first things it does is call this one. So every time you define a class in Ruby and you want to make something brand new, it's going to call initialize, whether it's defined or not. So to fix this, I'm going to say, I don't know what kind of animal this is, but it weighs 250 pounds. So now watch what happens. Oh, it works. That's not quite what I was looking for here. I'm going to call the toString method, and it should show us a few more details, I hope. Or maybe inspect. We'll see which one works better. Okay, let's try inspect. Just different methods. Inspect should show me what's defined inside this class. Oh, and there it is. So there's my instance variable, which is a variable now available with information inside of it, available to every single method inside this class. Where this becomes useful is if I want to define a method like this. So I say def weigh. So I'm pretending I'm a veterinarian, and I got I don't know what it is, shooting, so maybe a large dog or something. I put him on my scale, and this is the action I'm performing on the noun. So I'm going to just print out some information. I say puts I weigh, interpolate this variable, weight. So that's the instance variable. Oops, I weigh this many pounds. I never actually defined this variable within the context or within the scope of this method, this weigh method. But since it is an instance variable, and since it was assigned immediately upon the creation of this instance, upon the creation of this object, this now becomes available. It's stored here in memory, and I can retrieve it at any time. And that's all I'm doing here. So I've created my animal. We're going to do something a little bit nicer here. We'll say animal weigh. So I've defined my own method. I don't think you guys have seen that yet. You put dot weigh on this thing, it calls this guy right up here. So let's run that. So we should see 2 lines of output. And there it is. Here's the string representation of that object. And here is what happens when I call that weigh method. It just puts it out to screen. So animals are a really broad scope. We could say now define a subclass, a child class, a class that inherits off of this animal class. And since we're using animals, we use descriptive class names and variable names and all the rest. I'm going to say this is a class dog. I don't own a dog, but I consider myself a dog person. I like dogs. To make this dog inherit, so to adopt all the properties of the animal class, we use this notation, that less than sign. So you've already seen this in the ActiveRecord classes, and the name of the class from which it inherits. So let's clean this up. Well, let's animals, the animal class. And just to sort it out, and this will be useful in your notes, I think, I hope. Dog class. And I'm going to do the same thing. All I'm going to do is instantiate, create a new instance of the dog. Dog.new. Put dog. Put dog.
Is it one that through its capital?
Yes, it does. This is very important, and thank you for that. That's a really great question. Class names are always capitalized, always, without exception. In fact, you'll probably even get a syntax error. A lot of languages are pretty loosey-goosey about this. Ruby, I don't believe, is one of those, but you can test that out for yourself. Class names are that noun. This is an animal. This is that class, that blueprint, and it's denoted with that big D or that big A. And every single instance of this class is denoted in lowercase. Ruby convention probably will get you in trouble if you start violating these rules. Well, let's try it out. So I'm going to make this a small dog. We'll say he's 15 pounds. Run the program. So now I've kind of split up the output here so that you can follow along with what we're doing. Here's the animal class. Haven't changed anything there, just showing you the string representation of the object. Same thing with the dog. And you know that this dog inherits from animal because I can define this way class here. If it doesn't inherit from animal, watch what happens. So I'm going to comment this out. Now we're going to get an error. We're going to get an undefined method. Dog is no longer an animal in this program, in this world that I've created here. So it gets pretty far, prints out the animal class, gets this. Oh, and then it says, okay, well, shoot, I tried to instantiate a dog. So it managed to print out this here. And then it gets to line 22 and it says, oh, you gave me one argument. I was expecting 0, right? So this is not an animal class. It doesn't call that same initialize. If I take this out, okay, so that'll solve that problem. Undefined method way. So now I can instantiate an instance of this dog, but I've never actually defined this way. So what I could do, I could grab this thing, I could copy and paste all this, put it in my dog class. It's still not inheriting from animal, but I can reset it. I can take this, and now it has a way method. Now it works. This dog weighs 15 pounds. Problem here pertains to dryness. I'm repeating myself, right? This is bad practice. I've got the exact same code here in my dog class as I do up here. Now, this isn't why object-orientedness was created by any stretch of the imagination, not to keep things dry, but I know that since I am repeating myself, I've done something wrong. Far better just to define this animal class, assume that all animals have certain properties, and then every child of that class simply inherit from it. So that means I can take all this stuff out and end up with the same results. And this is true for object-oriented programming in, I think, all languages. I can't think of any exceptions. It works. So I've kept my code dry, and I've adhered to the doctrine of object-oriented programming. A dog does, however, have certain things it does that other animals don't. For example, this certainly isn't unique to dogs, but you could train your dog to speak. So I'm going to define another method. I'll take all this stuff out, don't need it. It's all defined in the animal class. I'll say, okay, well, whoever this dog is, whenever I call speak, I want him to say woof. just like that. So I can weigh my dog, I have inspected my dog, and now I'm going to say, hey dog, speak. Woof, there it is. This inheritance doesn't go up the chain. The dog can speak, but the animal cannot. So if I take this guy and I try to make the animal speak, it's going to say undefined method. This animals in general don't know how to speak or to perform this trick. Undefined method speak. Questions? Okay. So let's do a couple other ones. Let's do a cat class. Do the exact same thing. We'll just, we know we're doing something wrong because we're starting to repeat code. But that's okay for now. So I'll define a cat down here. Use all the same stuff. Say cat. Oh, that's a cog. Ugh. Cat. Ah. All right. I'll do it the hard way. Cat. Cat. Okay, there we go. So how big is a cat usually? Like 9 pounds? I don't even know. It's a good snack for a dog, I think. Actually, I got no problem with cats. I kind of like cats. I wish I could rent a cat. I have a mouse in my garage. You come live in my house for a week and see if you can take care of that problem. So I'm going to run this program. Got 3 classes. 2 of them are inheriting. So I've got this cat weighs 9 pounds. So he's calling that instance method defined on the animal class. And he's also calling this customized speak method as well. So there's the woof, there's the speak. Okay, so I know like there's something's amiss here, right? So it almost seems like I need a class in between this animal class and this dog class. There's a certain class that sets apart from all other animals, and we treat them kind of special. So what I'm going to do is create an intermediary pet class. Pet's going to inherit from animal, and dog is going to inherit from pet, and cat is going to inherit from pet. So now we have 3 layers of classes. Well, there's actually at least 4, but don't concern yourself with that. There's a base Ruby class that just defines basic object behavior. 4 classes in total. The animal class, pets inherit from animals, share certain characteristics with all other animals, but dogs and cats are set apart. So they inherit certain traits from this animal class. If we run it right now, this is still going to work. At least it should. Let's try it. Yeah, so there it goes. The cat says meow. Program halts execution successfully. What I really want to do, though, is I want to somehow make it so that I can define one speak and have cat and dog inherit, or both be able to call the same method. So it's going to be a little bit different, but you're going to start seeing how this all works. So I'm going to put this ability to speak, because I think you could train a cat to meow, maybe. So there we go, there we go, there we go. Okay, so the problem here, I hope this is obvious, but the problem is going to be that once the dog used to say woof, but now when you call that speak method on either dog or cat, it's always going to say meow. So this is a problem. We're going to fix it. This is definitely a bug, but it's not like a terminal bug. See, so the dog, this is what he says now. He's some sort of confused dog. Now, there's a couple of ways we can approach this, and I think the best way to approach this particular case is to define that animal sound inside the initializer. You saw the initializer up here. So animal's going to have certain characteristics that are going to very rarely change anyway. I mean, or at least slowly change. An animal's weight will certainly go up and down. But there's no reason why we couldn't say define an initialize method so that it's called every time we create a new object and just assign some sort of greeting to this animal. So I'm going to do this. I'll say def initialize, and I don't really need anything here. I'm going to say, oh, is this going to work? Uh-oh. Oh, I need to define a class variable. Okay. Okay, yeah, that might be a little bit tricky. Well, let's try it anyway. I might fail miserably here, so just bear with me. I'll try not to take up too much time.
Can you define inside the method speak, instead of putting meow, you put a name of a variable?
That's what I'm going to try to do. The problem is I don't think it's going to inherit upwards, but let's find out. There's a way we can make this work one way or the other. So in this initialize, you're on the right track, by the way. I'm going to say this. I'm just going to call it a greeting. Greeting equals woof. And same thing for the cat. This cat, he doesn't say woof, he says meow. Somehow we've got to get this greeting, the value contained in here, into here so that we can do this. Oops. Something at least to this effect. Let's say ampersand greeting. Oh, I just thought of a better way. So this isn't going to work, but let's try it. Let's just see what kind of error we get. It's probably going to say undefined or unknown method or object or something like that. Oh, wrong number of arguments. From animals 35. Oh, I see. Okay. So what this is telling me, because remember, every time I make a new dog or cat, I have to assign a weight. So this is kind of an accidental lesson here. So it kind of fluked in my favor here. But somehow I've got to get this value, 250, or sorry, rather 15 and 9 for the cat. Somehow I've got to get it up here. So I still have to take this weight, and I have to take this weight here. And this still isn't going to work. Watch what happens. I weigh blank pounds. I weigh blank pounds. This one works, but not this one. Can anyone see or sort of see the problem here? I've passed it this value, but nowhere do I assign it to this value here. So this is why this is a happy accident, because there's a special method in all Ruby classes, and again, in all object-oriented programming languages, that let you call the method in the class above. We use what's called super. We can say super weight, and super weight down here. So this is calling all the way up here in this animal initialize. Now, to be clear, it actually does look for an initialize in the pet class as well. But since we didn't explicitly define an initialize, it steps from here, knowing that there's nothing, comes up to here and assigns that value to weight. So this is what the super method does. This is intro stuff. It's probably not going to impact you, but this should help you understand a little bit better of how these things work inside. So this time, now it works. I weigh 9 pounds. I weigh 15 pounds. Oh, and look, my greeting works too. So yeah, I guess it works. I'm just kind of surprised by that. Okay, so what other examples can we do? Are there any points that are just kind of murky here? We've covered a lot of different concepts, and I think broadly speaking, this is pretty simple. Animals and different subclasses: animal pet, animal wild, animal domesticated, like cows and pigs and all that kind of stuff. Different categories, and we can define them any way we want. Inside each of these categories, inside each of these classes, we define actions that we can perform on any object or on any class as a whole. Two special methods. The new method calls initialize, and the super method looks at the chain. So these are the concepts that we've covered. I don't think we need to spend too much more time, but if there are any questions or if there's any points of discussion, now would be a time to bring them up. Okay, well, let's hope this becomes a little bit clearer as we go. And in anticipation of the next step, I'm going to open up from last day.
Just to be clear, the super goes up one part of the chain, or does it go to the top of the chain?
It goes to the first one it finds.
Okay, so directly above.
Yeah, so in this case, and that's a great question. So when I call super here, cat first looks into pet. Finds pet, no initialize, no super method here, so it looks up one more time. And then it finds this one. So the very first one it finds the closest ancestor, you could say. All right. All right, I was getting pretty gung-ho there. Let's just see where this goes first. Okay, so getting back to the slides. These are the two concepts we covered: the class and creating individual instances of those class, and very high level coverage of inheritance. So in this case, now this is one you're all familiar with. You've seen the active record base. We've seen this house class. When you do something like this and you inherit off of active record, then you get a whole bundle of stuff that's coming in that you didn't have to define. Just like the dog and the cat class had their speak method, active record has a whole whack of them that let you do the CRUD operations. So this is the favorite example. And I think we'll use this one. So say you're a city planner, or you're in charge of the public libraries or whatever, and you've got to create a database. Your city, I think the example the slides use is in Toronto. Say we got the Calgary public library system. We've got, like 15 public libraries, probably even more. Each one of these things has books, physical instances of books. There's many of these books in print, but there's many physical objects. So you can already see this class and object relationship here. When we're talking about active record relationships, these things, the way we describe them are very natural. A library has many books. A book, of course, in turn belongs to a library. Active record makes it so that we can form this dual channel relationship, find a library inside of our database, find a book inside of our database, find out what library it belongs to. On the flip side, we can find a library inside of our database and find out all the books that it contains. Has many versus belongs to. This is how we define it. Very, very simple stuff. These are just methods that are called when you define your library or your book class. Again, very natural. The only thing that might look a little bit weird is that colon. This in Ruby, the colon makes this into a symbol. The symbol is a kind of a concept borrowed from Lisp, I believe. But Ruby's smart enough to know that in this case, we're talking about dual things here. We're talking about a table in a database, and we're also talking about a library model that we've defined. In fact, we've defined it right here. Vice versa, notice the difference here. The book only belongs to one library, singular, but the library has many books, plural. So if you're ever wondering when to use this pluralization, assuming that English is your first language, you will be able to say this very naturally and determine whether or not you should use pluralization. There's only one really weird exception to that, and it was justified by Matsumoto himself, and that was kind of one of these weird ambiguities in the English language. I'm trying to remember what it was. If it comes to me, I'll let you know. So, having defined our classes and assuming that there is, in fact, data stored in these classes, in the tables that correspond to these classes, we can retrieve information from our database. So we're using that kind of brute force. I know the ID record of this library. I can use the find method, get all the information about that library from the database. And what this does is it just takes a maybe street corner. What are other some stuff? Maybe heads of departments, all the information about different libraries. Nowhere in this table, though, does it have anything pertaining to books, which is interesting, right? At least I think it's interesting. The only reason we can do something like this, find the Toronto library, look inside the books, and get them all. So the the library's gonna have tens of thousands of books. The only reason we can do this is because of ActiveRecord. Without this, we'd be using what are called joins in SQL. So this becomes very natural way to connect these relationships and explore them. So here, the Toronto library is an instance of the library class. This is an object. Instance and object are basically synonymous. The books, this is that has many relationship. Without this has many books, this method here would not exist. And in turn, we would not be able to call the all method on the books method, or the books object, I guess. And then here, of course, that's that final all method that says, give me all the books that are currently, in the inventory at the Toronto Library. So, again, very nice feature of ActiveRecord. Not only can we find all the books, but we can find a single book in the library, find a single book in the database. We haven't even looked at the library yet, but using that book, we can determine what library it belongs to. This is made possible in two ways. The book is going to have a library ID encoded into its record in the database itself, and also, because of this, belongs to that we set. So this book we call library, and then we can find the name of the library. So maybe it's named after some civic leader or something like that. Okay, so instance methods. Okay, I think this is a good time to drop back down, and we're going to actually do this library demonstration, or maybe a kind of a truncated version of it. I was quite gung-ho a second ago, so I'm going to have to set up another one. That's not what I want. There we go. This repository has always proven very useful to me, even in my own in my own projects, because it lets me do this stuff really fast. So we'll say September, week w4d1 demo 2. Active record libraries. Library example. Okay, we'll let that fire up here for a second. We don't really need any of the fancy Sinatra stuff. We just need to create that connection to the database, create some seed data, and start playing around with Tux a little bit. So I've got a little bit of some stuff ready to go. So I'm going to do a lot of copying and pasting here. Oh, maybe we can work together on this. Okay, got to do a couple of setups. Gem install bundler. Bundle install. And then I need that just in case we end up looking at it. So this is actually a lot of review from last day. So you're going to see that whole process whereby we create the database, we migrate the database, then we seed the database, and if necessary, reset the database. But I don't think we're going to have to do that. Whoops. I misspelled install. Installing dependencies, some more good review. This is every piece of software defined or listed inside your gem file. Just taking that all off of rubygems.org. You can publish your own gems. This is all just stuff that people work on. It's open source. You'll find in web development there's very little proprietary software. All right, and then the runner. So we're gonna make a few modifications here. We've got our models. We're gonna change these. We're gonna recycle this. We want what do we want? We want libraries and books. And these are singular. We'll change this to book. And this one to library. Should we really push it and define an author as well? I don't know. We're running out of time, so we won't push it too much. We'll keep this really simple. So I've got my models, and I've got a way to talk to the database, but we haven't actually set up the database. Without the database, these models are going to be absolutely useless. So if we come down to DB, and I'm just recycling the old stuff from this base Sinatra project, and I'm going to create a libraries. And ActiveRecord is smart enough to find these like wonky pluralization because, a lot of times we just tack an S on the end, and then we have these weird ones like library. We don't say YS, we say IES. Sinatra is, not Sinatra, ActiveRecord is pretty smart in that respect. We'll call these books. And books reference library, singular. What else does a book have? Title, T string. What happened there? String, author, and what else we got? We got name for the library. What other features? Was there anything on the? Oh, we got an author class too. Okay. I think it just had name. Okay, that's fine too. Actually, you know what? Even better. We'll just say city. We'll keep it super simple. City. And you know what? Since it is mentioned, we'll say authors as well. So we'll say first name, last name, and we'll change this one so that's a reference. So this is establishing those relationships. This was what makes it relational. Get all this. So there's our migration. We still need another model. We'll call this one author. And since I copied and pasted it, I have to do this as well. Okay, so at this point, we could try to create our database, and that's actually a really good idea. We have a migration. We have our models. We don't have any data yet, but we can get to that. So to do that, we do this bundle exec rake db create. Now, I don't think I already have. You should see a file appear here. That's that db SQLite file. Looks good. Okay, so empty database, no tables, no nothing. Now I'm going to perform that migration. This is just going to assign or show us our tables. Rake db migrate. If I keep my fingers crossed, I didn't mess anything up. It worked. Wonderful. So at this point, we can go into Tux, and we can see what's contained in authors by using what's called a class method. So this is a little bit different, and we don't really talk about it too much. What you saw when I was defining those speak methods or the way methods, those are called instance methods. And you're only going to call it on, say, for example, the lowercase d dog. Lowercase d dog speak, lowercase cat speak, etc., etc. An instance method is immediately recognizable because we're calling it, or sorry, a class method is recognizable because we're calling it on the class itself, not an individual instance of that object. So when I do all, this is called a class method. There's nothing in it. You just gave me this empty bracket. So let's define some data. I like to use seeds. And we've already got a whole bunch of stuff in here. See what I can do to recycle it. So let's say we got some authors. What did I do? First name and last name? Last name. Whoops, that's wrong. So we'll get rid of that, because I like to go fast. I'm just going to come up with 3 authors, so you guys can help me out here. Probably the last book I read for fun was by a guy named Thomas Pynchon. Any other suggestions? I'm not a big reader. Who likes to read? Who's that?
Ernest Hemingway.
Ernest Hemingway. Beauty. All right. Ernest Hemingway. Did I spell that right? Okay, one more.
Let's go Stephen King.
Ooh.
Let's go.
Stephen King. There we go. Yeah, we're going to create all these authors. Here's that create. This is actually another class method. Author. And okay, so now let's talk about books. No, let's talk about libraries. And I kept this really simple. I just have cities. So we're not even talking about like a one city's library system. We're talking about the whole country. And we'll pick a few. Actually, first we'll get rid of this. And we'll say Calgary, Edmonton, and since we already used Toronto, just because that was the example. Strange no mention of Vancouver, because I mean Lighthouse Labs is based out of Vancouver. Okay, and then finally, oh wait, we still got to do this. Libraries. Does everyone understand what's happening with this each method? This should all be review, I think. So what it's doing, just as a recap, got an array. We've got an array of hashes. And then each time through this list, it looks at this one and creates a new one in the city of Calgary. Looks at this one. That's what each does. Creates a new one in Edmonton and then Toronto. All right. So we got authors. We've got libraries. Now we need some books. Books equals proper indentation. So what's we need a title, and we need an author ID. What's an easy way to do that? Books author ID. Oh, that's a good one. Oh, this is tricky. Okay.
Can I name like their first name?
Well, no, actually, no, they can't. Yeah, don't mess with IDs. Like those are just automatically set. There's never a situation where you want to play around with those. So we'll give the dust jackets description, and then we got to figure out, okay, well, author ID, because this is going to be written by someone. So this is very manual stuff here, right? This is it's kind of tricky, but let's say author find by, and we'll say last name. My guy was Pynchon. And library ID, because this book belongs to a library. And we'll say library find by city Calgary. Can you see why I'm doing this? Or is this just like weird stuff to you guys? Oh, I don't need that. Okay. Let's spread this out so we can get a better look at it. Description. Okay, so that's one. I'm just going to use this as a template so I can save myself some typing. I'll make 3 of them. So we got 3 authors, and they each wrote 1 book. Okay, so my guy wrote the book. This is the last book I wrote. It was called The Crying of Lot 49. Hard to read. Mostly about drugs and the Beatles. Okay, so that's Thomas Pynchon. Well, we had Ernest Hemingway. Old Man in the Sea. Old Man in the Sea. Some old guy in his boat. There we go. And, oh, no, sorry, we need Hemingway. And we're going to send him to Edmonton. Stephen King. Now, I've got a favorite Stephen King novel. What's yours?
I can't think of the name of the one with the weasels.
The
I
Weasels?
censored myself. The shoot weasels, I can't remember. Oh, Dreamcatcher, I think.
Dreamcatcher? Oh, I don't think I've read that. I would have picked...
I think it has to go up the line.
Whoops, yep, you're right.
But I was going to go with it, and your description can be rented on video.
There you go. It's just as boring on video, too. Just as boring on video. I read it. Yeah, that was like, what, 800 pages?
My friend's little brother used to rent it on VHS, and it came in 2 tapes.
Yeah, I don't know. Okay, so we got a whole bunch of seed data, and I hope I didn't mangle anything. But when we do this, it's gonna populate our database. So next time assuming this is successful. Oh wait, I missed a very critical step. I actually forgot to create this stuff. So we'll say books, book. This is just ordinary Ruby, nothing magical. Okay, so fingers crossed. I'm going to say bundle exec rake. Did I spell that right? DB seed. Something kind of went weird there, but let's try it. Oh, something went wrong. Oh my goodness. What happened? Oh, first name. So it doesn't like this. How did I make? If you're questioning like what does your database actually say? The question that's been raised here is telling me that I didn't define a first name column in my author database table. And if I want to find out for sure, I can look at this schema RB. Now, just a warning, this is free for you to look at, certainly, but you're never supposed to touch this. This is something automatically generated when you run these rake tasks. So, first name ID. Oh, I messed something up. Library ID, author ID. Do you know what I bet? So we're going to look at the migration, and I think I said references first name and references last name. Big mistake. So we can come back to here, check our migration. Yeah. No. Authors. Yeah. String. Wrong data type. So you see what? That's kind of a nice actual little accident as well, because if you look at this thing, it thinks I'm trying to establish some relationship. That's what that references does. It just creates that integer, which is that database ID. Okay, so fixed it. And since I set up seed data, this is pretty trivial. All I need to do, say bundle exec rake db reset. So that should recreate my database. Migrate. If a task is mundane, the first thing you should be doing is trying to automate it. And this is, this is a nice way to do that. So I've created it. Now I seed it, and just to show you that something has changed, if I look at my schema now, actually I guess I'll have to close it. If I look at my schema now, that problem is now fixed. First name is a string instead of first name underscore ID and last name underscore ID. Okay, so now I'm going to seed it, fingers crossed again. Oh no, another problem. Could not find table books. So this looks like it's in my seed table. Could not find table. Oh, another problem. Look, books, singular. Oh my goodness, right? Welcome to my world. All right, so this has to change to this. And again, since I had the foresight to make this really fast, I can just keep doing this over and over again. Migrate. Okay. Oh, it's getting closer. It's getting closer.
This is how we feel when we move along to our.
I know, and I empathize with you. I seriously do. You wouldn't believe some of the stuff that will trip you up for days at a time. So now, what does it say? Unknown attribute, description. Did I not put a description in my book? I didn't. Hopefully I spelled that correctly. Whoops, that time I didn't. Okay. Slowly but surely. Oh. Seed. Ugh. I'm trying to think of some examples where I've been tripped up for days that you guys might be able to appreciate. It worked. Can you guys tell that it worked?
about failure.
When you start seeing stuff like this, let's find a really bad one. See, like this. When you start seeing like these paths, you know something went wrong. These are paths on the file system. Down here, I've got a whole bunch of nicely formatted SQL. Got to the end, everything's good. Okay. So now at this point, we can run tux, and we've got a whole bunch of data we can work with.
Is your computer like a different time zone?
Yeah, probably.
Okay.
I think Cloud9 is usually Eastern Standard Time. Why do you say that?
Well, because you can see the updated that. Is today the 28th?
Oh, look at it. So it's way later. I wonder where that is.
Yeah.
That's a way different time zone. Yeah, so like, this is the not the consequence, but this is one of the things that happens when you work in the cloud, right? You have no idea where your servers are. Well, we got some idea, but I don't know where. It's 1:30 in the morning at the moment.
Where's IO again?
Oh, IO is where? Sorry, which one?
Where is IO like located?
Well, anyone can register IO, but IO stands for Indian Ocean. Yeah, actually, I just noticed today GoDaddy is registering IO domains. So, reason why Cloud9 uses IO, because IO stands for input output as well. So it's kind of a trendy thing. One thing I forgot to do though, but let's look at this. Let's say look at author.all. Oh, so we got a whole bunch of them. We got book.all. And let's just say something like this. So book equals book.first. So this is just going to be the first one on the table, right? Lots of different methods like these. We could spend days covering all the different ones. If you're curious about how to do it, chances are someone's already made a method. So here's my book, The Crying of Lot 49. At this point, I should be able to find out what library, but I won't be able to. I should be able to do this, library.city. So it's a little bit of a departure, but it's going to say undefined method library. Undefined method library. Pretty good, right? So I missed something. Let's look back on the slides. We should be able to say t.book library.city in our case, but we forgot to do something. We forgot to establish these relationships in ActiveRecord. I forgot to tell ActiveRecord that a book belongs to the library. So I come back to here. Here's my book class belongs to, and that's a symbol, a library. Likewise, library has many books, plural. So now we can do that. We're still missing something though. Let's try this out. We'll run tux again. So I'll find my first book, just like I did before. And now I should be able to say library.city. Undefined method city. Undefined method city. That's not right. What happened? Did I forget to save? Say book.library ID. Nil? What? So something went wrong with my seed data. Oh, I need IDs. Which one?
When you say book.library ID, that library shouldn't be capital?
No, not in this case. No. The only time you're ever going to see capitals is classes, constants, module names. Typically, a good rule of thumb is just to stick to lowercase. I forgot something. I forgot this. I just want one piece of information. It's that library ID. So, back to the drawing board. Control D. Just my computer stopped. What happened? Okay, bring up a new terminal. Nope. Where's my plus? There it is. New terminal. Okay, bundle exec rake db reset. Migrate, just starting everything fresh.
What does that ID, I want to call it a tag at the end, do?
That's well, it's not. It's a method, but that's getting that piece of information. Remember how our records are sorted into key value pairs.
Yeah.
So the ID is that automatically generated number or string that makes this unique in the database.
All right, so it makes it a particular, it gives it a particular ID.
Yes, exactly. Everything in a database has a unique ID, one way or the other. So we'll seed that. I thought I'd forgotten one thing, which I did on purpose, but then I forgot something much more critical. Okay, so tux, we'll say book equals book.first. Book.
So do you have to do it in that order?
What do you mean?
Well, because every time you've been doing the book dot first and then going to the library ID, but the book dot first.
So these
every time.
these are CRUD operations. Yes. So well, yeah. Let's run through that. That's a good question. Here's the C in CRUD. This stuff I just automated because I've had to do it like 4 times, right? So I keep doing it over and over. This is the C in CRUD. Create. When I do this, when I say book.first or find me a book called Crying of Lot 49, whatever it may be, this is that read. So I'm reading from the database. So to answer your question, in this case, yes, you have to actually draw something out of the database before you can start performing these operations on it. So now I know that this should work because if you recall, hopefully you were paying close attention, this was nil before. It didn't exist. Now it equals 1. So I should be able to do this. Book.library.city, and it says Calgary. There we go. If you're curious, you can do this as well. Book. Maybe not. I might be thinking of a different language. It might be actually a second. It does. It works. Okay, so book.library.city. This one is in Edmonton. Okay, so that's that relationship, and vice versa. So we can say library equals library. We'll say let's try a different example. We'll say find by. The end result will be the same, but I just want to show you how you can use these things to read. So this is the R. City, Edmonton. Like that. Okay, and so now I can take library and call books.all. Of course, we only have one, but I think it was Ernest Hemingway, yes. Old Man and the Sea. So we've established that 2-way relationship now. We are missing something, though, because we should be able to do this. We should be able to say book.author.firstname, but we forgot something. We forgot to define that relationship in here. We're not limited to just one. If you recall, when we created this database, we said that a book belongs to a library, and it also belongs to an author. Just like that. So now if we run tux again, on Earth, it hanged itself again. What's going on? This one's still gone too. Okay. That's a little weird.
So when those freeze like that, because it happens to me a lot, it doesn't matter if you just close them.
Oh,
It
no,
won't
no.
impact anything that-
Well, it will impact something, but even now it doesn't. I was going to say it probably will impact your history, but even now I can cycle through all the previous commands. But no, it's not going to ruin anything. It's kind of like even resetting your computer in a way. So, okay, so let's just grab, we'll say, let's really push our luck here. We'll say we tried first, we tried second, and there might be a third. It did, it worked. How about that? So book.author, Stevens, all the author details. If we just want to know one thing, We could say first name. We could say last name. We should also be able to say has many books. We haven't set that up. Author has many books. Just like that. So I don't want to keep beating this dead horse, but you've seen this with the library, the relationship, and all the rest. So now like all these things are kind of coming together. Let's look at this last concept in the slides. Active record relationships. Probably don't need to go full screen, but I'm going to anyway. Okay, so now we're talking about instance methods. And now a good example of this is that speak method, or the way method I used in that animals demonstration when I was showing you object-oriented programming. These are just classes, just like those. The only thing different about them is that they're inheriting off this active record base class. But we can define anything we want. And the example used here is that, maybe we just need a shorthand for the author. We just want to find that first name, the last name, and output some initials. So let's grab that, just because I've been very bad about time this class. I'm going to copy and paste all this and put it inside my author class. Oh, did I just ruin the slides? Okay, there we go. And I just define it down here. Self first name. Well, this is a little bit different. I didn't put these underscores here. What do you suppose this thing's doing? Not the first record, no. Or even better, what do you think this is? Self. Self. Okay, we're getting into some deep concepts here, right? We can only show you so much, but self is the object itself. It's like introspective that way. So if I'm creating an author, it has this notion of self, and we retrieve that, we find that and exploit that notion by calling self inside these method functions. This self.last name, this is just the database record. So it's looking at that column, it's asking, well, what's contained inside here? So if we use Stephen King as an example, self.first name is going to be Stephen. Self.last name is going to be King. And you should sort of be familiar with this. This is how we index arrays. Here we're indexing a string, which is okay. You can do that. We're just taking the very first item, because remember, we start counting up at 0 in Ruby. So we're going to get S, going to interpolate it. There's no space between it, and find the K. So let's give it a try. Now, this keeps causing me all these problems when I try to exit out of here. So, okay, that time it worked. Whenever you make a change like this to your models, you have to restart Tux. And I don't expect that you're going to be using Tux a lot firsthand, but just be aware, because I know this was a common question from last day. So we're looking at author, and we can do another example. Find author. Find by, we can use these last name. We'll use Stephen King. And bracket. Hit enter. Okay, there it goes. Reads from the database. So if I type in author dot initials, it's going to call this method. It's going to look at itself. It's going to find the first name, going to find the very first letter in that first name, find the last name, spits it out to the screen, SK for Stephen King. Yeah, pretty cool stuff. All right, and I think that's pretty much the end of our slides. We'll go back to full presentation mode. Yeah, those are instance methods. I don't think we really need to look at that too much. Yeah, so now we're at the end of our slides. I've been having some good questions during these kind of lulls. I always appreciate those. Any other questions? Anything at all? Okay. I will get to work summarizing the lecture, and then after that, we're both at your disposal.